from the sun to bring electricity back to the island. Ready to leave Earth? Buckle up! We're going to space to visit the sun. All aboard the rocket twin. Hopefully we'll learn enough from the sun to bring electricity back to the island. Ready to leave Earth? Buckle up! Afternoon, wherever you're coming from. Welcome to the live STEM show here. My name is Eileen and I'm a content developer with Twin Science and Robotics. And I'm here with some of my best friends, Jihan, Ethan, and Yeet.
Hello, Eileen. How are you?
Good. How are you doing? Can we hear about who's joining us today, Jihan?
Of course, I'm feeling good. I am in Istanbul now, and it is like evening time. We have a nice weather today. What about you? Where are you at?
I'm in New York City for the day, and then later in the day, I'm going back to San Francisco. So
busy day.
Yes, very busy day. And we've got Ethan with us. Where are you coming from, Ethan? Can we hear about who you are, where you're from, how old you are?
Okay. My name is Ethan John Anish. I live in UAE and I'm from India. I'm 9 years old and I have two smaller twin sisters.
Oh, wow. Very nice. Thank you for joining us. How about you, Yeet? Can you tell us a little bit about yourself?
Yeah, for sure, Eileen. Hi. I am currently in Eskişehir, but I study in Harvard University. I'm currently pursuing a double major in neuroscience and film and visual studies. I'm super excited to participate in this live STEM show and ask questions and learn more about science.
We're very lucky to have you here. Yeet is actually at Harvard University, and we're so excited to have you as one of our role models. And we can't hear more about you and what you can share with our students and kids here today. So welcome everyone. It's good to have you again, Ethan. I know that you've been to our live STEM shows before. This is my second one. Jihan, of course, is the Master STEM Show host, so we're really excited to be here and to start our adventures. Everyone ready?
Yes.
Okay, two thumbs up.
I think like the adventure trailer was perfect. I love the music as well. Please, if any one of you guys who are watching now, if you haven't tried the new adventure, we are going to the Sun adventure with the voice of Eileen. Please go to adventures and try it and send us your feedbacks.
Exactly. It's a really fun adventure and we can't wait to get started with you. But before we get started on the STEM show, we're going to just tell you how it works, okay? So you're going to be, everyone on our app, the Twin app, are going to see your screens like this. We're going to be talking about really interesting topics, and we're going to have questions popping up every now and then and talking about those questions. You have 20 seconds to answer our questions, and it's going to look like this. You're going to tap on your screen on what answer you think is correct, and after you've tapped on it, after 20 seconds, you're going to see if you're right or you're wrong. There's going to be a leaderboard, and we're keeping track of who's answering the questions correctly because at the end, if you win, you get a robotic art kit. So everyone who's not joining us on our app and is joining us on YouTube next week, 3 p.m. GMT every Sunday, you can download our app, Twin app. You can download it with this QR code on your screen. You can click join now on the main screen there and answer our questions. And every week, a winner gets to take home a robotic art kit, which is great. Very fun.
Yeah, I have that kit, and now it's done. Yeah, I used it a lot. The paint is done, the chart paper is done, everything is done.
I say totally. I'm really excited. So why don't we see what our first screen is, and we're gonna just kind of dive right in and go straight into the questions. How about that?
Yeah, perfect, perfect. So maybe we can start with question one, but before that we have a clue.
Exactly. So on your screen, you should be seeing something like this. What do you think it might be, Ethan? What do you think you're looking at?
I think it's stars because it's full of light.
Wow, yeah, and there's a lot of different color stars, aren't there?
Yeah, but I don't think so it's stars because I've never seen red and blue stars.
Yeah, well, you see red, blue, white, yellow, a lot of different colors here. And I think you're correct with the stars, but we're going to figure out why there's so many different color stars and what that has to do with space, temperature, and everything. So, which of these colors is not a color of star that we can see in space? On that screen, what colors? You saw red, yellow, white. What color did you not see?
So
Let's look at it
now we are collecting answers from viewers, Eileen, uh, and I am seeing the responses.
What's it looking like? What's the consensus?
I mean, we have different ones, but the consensus is on green with a little bit like more vote, let's say.
Green, exactly. Let's see. Is that a correct answer? What do you think, Ethan? What answer do you think?
Yeah, even I think it's green because I did not see green stars.
Yeah. Why are there so many different colors and not green? Like, what do you think red stars mean versus blue stars?
I think so. Red star. The stars become red when the temperature is too high.
Wow. Which one do you think's more hot? A blue star or a red star?
Red star.
Red star? What do you think, Yeats?
I would I would say blue because like if I remember correctly, blue is has a higher frequency in the electromagnetic spectrum, but I'm not quite sure. I would love to know.
Wow. So I just heard a big word, electromagnetic spectrum. That was like, maybe we need a pause here. Let's look at something explaining what that is. And I think this, Ethan, if you look at it, you're seeing a lot of different colors. We're talking about temperature and we're talking about colors and temperature and how, and I heard the word frequency too, right? You said frequency? Well,
Yeah,
if we're looking at this, what can you tell me, just Ethan, looking at this screen, can you
By looking
explain?
at the screen, red, orange, yellow, and green have low frequency in electromagnetic spectrum, and the other colors have high frequency.
Yeah, and so if it's high frequency,
That
more
means
energy, more heat, or less?
more energy and more heat.
Okay, so it looks like you answered my question just there. So a blue star is hotter than a red star?
Yeah.
Yeah, and it looks like those shine brightest too. So that's really interesting to me. Perhaps we can like see what that means like in our everyday lives. Maybe by watching this video, we can walk through something like stars are so far away. Let's bring it back home and somewhere that we can find in our own hometowns. How about that? I see a blacksmith right now hitting what is that a horseshoe?
Yeah, definitely a horseshoe.
Yeah, I so iron's black. You see all of the like black iron right there, horseshoes, but one of them was what color is that? Is that
It's
orange?
orange.
It's yeah, I see a couple of colors actually if you look really close. In the
Yeah,
middle,
I can
isn't
see
it?
red, orange, and yellow, and I can see a little bit white.
Okay. What okay, so now that we know colors kind of like connect with temperature, which of those colors do you think's hottest?
Hmm. I think so. Yellow is the hottest. If there's white, then I think so. White is the hottest.
Hmm. What do you think, Jihan?
I think same with Ethan. I mean, it's like, I mean, I know if it is cold, it looks like black, right? This is iron. This is iron that we know, and it looks black. And black is this side, so this side should be cold. And as we go to the other side, I see red, orange, yellow, and a little bit white, whitish colors, like our sun. So it should be like increasing. The temperature should be increasing. I think Ethan is right.
Wow. So I think we have a video like explaining this. Like horseshoes appear black at room temperature,
of light
but
equally.
black absorbs color, right? Like when you're in the sun and you're wearing a black shirt, you're pretty hot. Well, right now it's absorbing the colors, and as you heat it up, I'm seeing like different colors of the horseshoe changing blue, white, yellow, red, and it looks like we were right. Blue is the hottest part of the horseshoe. I didn't see blue though in the horseshoe. Did you see any blue? Anyone?
I did not see any blue.
No, me neither.
No. So that's crazy. But we saw blue stars.
Yeah.
Jihan,
Yeah.
can you explain a little bit about that? Like, why are we seeing blue stars but like not blue iron?
Yeah, I think the like materials. It should be something about the materials. Like what I know about iron, like if the temperatures go higher than this part, maybe 3,500 Kelvin or so, the melting point starts. Like the melting point of iron starts, and the physical properties change, and like it disappears basically. Like we cannot see the solid material as it was before. But for I think stars, it is different. The materials and the maybe physical properties of that materials might be different, so that as the temperature goes higher, even though they can stay together and reflect more high frequency electromagnetic waves, and we see those stars as blue.
Wow. Here's a just like quick question. I think it's a bit like trivia, but iron has a melting point of like a high melting point, but stars, what do you think a star is made out of? Like what thing allows it to be this hot and turn different colors that iron can't? Ethan, do you know maybe what a star, like what element it's made out of? Like our sun?
Yeah. Sun. Some people say no. Sun is a star also, and sun is made out of fire. Sun is mostly fire. So I think so. Even stars are made out of fire.
Interesting. Neat. What else do you think is a sun made out of? Like what makes it burn that hot and bright to be blue?
That's a great question, Aiden. When I think of stars, I think of them as like objects that have huge masses. So that brings into mind something related to gravity. Maybe like I don't know what they're made out of, maybe, but there's something about gravity that pulls the atoms together and it compresses them, which kind of maybe like heats it up. I'm not sure. What do you think?
I think that's a really good start. Like, you got a lot of energy being put into one space, and so it gets really, really hot. But from what I know from school, is that suns are mostly made up of hydrogen and helium, not iron. Iron is like something that we find in a solid form here on Earth, and they're quite dense. But I think exactly what you were saying, gravity is pulling something really, really tight in the sun. And so now you have things like gases, like hydrogen and helium. Gases are starting to like become more of a solid object, and they're burning really, really bright. And look at that, they're able to turn into huge celestial bodies. These suns, I think, are many, many times bigger than our sun, perhaps, if they're that big, bright
But
red ones.
wait, Eileen, I have a question about this.
Yeah.
Like when Ethan was Ethan, by the way, we cannot see your face. Can you like yeah, a little bit go higher? Perfect, buddy. Yeah. So in this spectrum, I see green after yellow, right? Ethan, right? You see green.
Yeah.
And the question was related with this. We were not able to see green stars, right?
Yes.
Let's remember again. We are not able to see green stars because there are none, maybe. So then we go back to spectrum, but we see there are blue stars, there are yellow, orange, and red stars. Why don't we have green stars? Like we see white instead of green, right? So he was heating it, right? And in here, let's look at again. So we see white instead of green. Why is that? Do you know, Ethan?
No idea.
No, I think Eileen can enlighten us about this.
Yeah, of course. So I know a little bit about it, but what I can say is that after 6,000 degrees Celsius, 6,000 degrees, black bodies, these things called black bodies, start emitting three primary colors. The three primary colors are red and green and blue, okay? In the same amount. So when our eyes receive these three colors in equal amounts, we see them as white. So when they're all combined, you see the color white and not green.
Oh.
And the color visions in our cells, how we see color, they perceive these primary colors, the red, green, and blue, as white when we see them. So perhaps we are seeing green, but our eyes just don't perceive them in the way that we would think we perceive them.
Yeah,
So we can see green leaves, perhaps.
like because red, green, blue, they join their forces and come together to us, right? And then if we see equal amount of them coming from all around, like to us, we see white because they join and form white. As I understand it now. Yes, Ethan?
So Ellen told that when red, green, and blue mix, it makes white. So in the picture there were white stars. So does that mean those white stars are made out of red, blue, and green?
Wow, that's a great question. What do you guys think?
I think so. I don't know.
I think so too.
Like,
I think you're right on that one, because light travels in waves, right? Kind of like exactly what we were seeing in the electromagnetic spectrum, the frequencies. And so there's certain frequencies that are, when they're blended, at an equal amount of red, green, and blue, we see them as white. So I would say that's a great question, and I'd say, yeah. How about you, Jihan?
yeah, I remembered rainbows directly when Ethan was explaining. Like our sun, it is white, right? It has a little bit yellowish white, but it is white. And as like sunlight passes through a prism or a raindrop, we see rainbows, the colors in the electromagnetic spectrum. So yeah, it's like now I understand better. Thank you, Ethan, for that question.
That's a great question, and I love rainbows and see. I think it's magical to see white light being changed into these colors. So our eyes don't always see every light out there, and now we know it has to do with how we see, and it has to do with temperature and frequency. So all of these things, there
Right.
seems to be a lot to discover about the universe out there.
Yeah,
Um, I had
perfect.
a question maybe about. Do we have time to go into black bodies, Jihan, or shall we move on?
I think we can move on, Eileen. I will show the results first, and viewers will be able to see now their answers. And Adam Wallace is at the first rank, so it's pretty nice to see everyone is following up. And we will be like skipping to the next question, but again, we have a little bit clue about the question. So here is another video, Eileen.
Awesome. Yeah, let's check this video out. Keep on tuning in, and questions will follow, and keep on answering. So, what are we seeing right here, Ethan? What do you think that is?
I see a fish.
A
A
fish.
fish?
It's getting close. It looks really big to be a fish. We're getting closer.
Hey, it's a whale. It's a whale.
It's a whale. Exactly. It's a whale. And why do whales like? What is it doing? What's like? It's spraying water. Why do whales spray?
It's
out
coming
water?
up to get oxygen.
Oh, very nice, Ethan. Okay, so it is doing something, and it is doing something big, right? What do you know about mammals, Ethan?
Mammals, they breathe through lungs, and a whale and a dolphin is the only aquatic mammal. So
Uh,
they have a hole on top.
okay, don't go in there, and we will continue after the question. Okay, Eileen, let's have the next question.
Yeah. Why do whales spray out water? Is it A, to give birth, B, to see the sun, C, to breathe, or D, to capture prey? I think Ethan
Yeah.
really helped us out with that question, but all of them are really good guesses. There's a lot of things we can discuss here, but let's see. We have maybe 10 seconds left.
Yeah.
See what everyone else thinks.
I
And-
collected all the answers. Everyone actually. So it was a nice clue, Ethan. There's a consensus in here, and everyone thinks that they go out and spray water to breathe, and the answer is C. But let's learn a little bit about mammals. And Ethan, you were explaining why mammals like whales are not fishes, right? Whales are not fish. Why?
Whales and dolphins are not fishes because they have lungs.
Okay, so
Yeah.
how come? Like, how come they have lungs and no any other species has?
That's the thing which I have no idea about. I do not know why whales and dolphins have lungs.
Jihan, I have a question. Like,
Yeah.
would okay, so we agree that whales and dolphins do need oxygen, but do fish also need oxygen? Like fish that are not mammals, do they need oxygen as well?
That's really good. No, you think no, Ethan?
No,
No.
Well,
except
surprise me.
except two types of fish: the African lungfish and one more fish. I forgot the name.
Wow,
So-
I didn't know about that about the African lungfish. I believe so. What do gills do on a fish then? Why do fish need gills if they don't need oxygen? What is that function?
The fish use gills to get oxygen from the water.
Okay, so they are in a sense breathing, but not through lungs like we do, inhaling. In a sense, it's what, filtering the water for oxygen, those gills?
Yeah.
Okay. So in a sense they are breathing, but there's oxygen in the water and they just don't need to come up for air. They can get the air directly out of the water through their gills. But let's go back to like the reason why do dolphins and whales even need to breathe? Why do they even have lungs? Any clues?
So
Yeah, well-
Ethan, let's become a fish, okay? So and like through 1,000 years, okay, we are getting stronger and we are getting bigger. Lots of different fishes are like evolving, okay? And after some point, one, yeah, please ask. Yeah, yeah, Ethan.
I remember from last year's STEM quest, there was a question saying that do whales and were whales land walkers? And from that, I remember whales would swim, and then after a long time, they were land walkers also.
Yeah, so you remembered it right. So once they go up to the air, I mean to the land, and they were like trying to get oxygen on the land from air. And throughout the years, maybe thousands, millions of years, like lungs have evolved. And then they decided to go back because they missed their home, water. And dolphins and whales are two examples of that.
Exactly. So imagine whales on land. They're huge. I think they got bigger when they got in the water, right? It's really hard to be that big on land. So they got big lungs. They have these things. What is the thing on a dolphin and a whale on the top of their head, like that, where they breathe out of?
A
What do you,
blowhole.
a blowhole? And they're obviously, you can see they're blowing out air and some water right there. Exactly. And then in just a couple of seconds, they refill those lungs to go back down. So yeah, they used to be land mammals, breathing, walking, crawling, whatever they were doing, and then they just went back into the water, and now we see mammals living in water coming up for air like this, and I think it's incredible.
Yeah, and always like it was a question to me. Like when I was a kid, I always was asking this question: like, how do they feed their like little whales?
They're young, yeah.
It was strange, and here we can see like example of it. They really feed their kids with milk. They give birth and milk their youngsters through their uh, mammals. Like it was very strange for me because you are in like water, but still you are breeding your youngsters.
Yeah, I think that's something very unique to mammals. You know, do you know any fish that might feed their young with milk? I think that's a mammal thing. What do you guys think?
I agree.
Yeah, so breathing and feeding their young with milk.
Mhm.
So keep that in mind when you're looking at other aquatic animals left. If they do either of those two or both, you can guess that they're probably mammals, and they were once upon a time living on land with us.
Mm. It is a nice information, piece of information. I think Ethan, you will not forget, but you remembered, but you will not forget this time. It is doubled, right? Now we know it for double time. So let's look at the results again. Okay, it's getting good. We see some like four of the viewers are going on top, and Analalus is at the first rank still. And now we will move to the next question, Eileen, if everyone is ready.
Sounds great. So we're gonna watch another video. So pay attention, and we'll talk about what we're seeing and ask our next question.
Human
And again,
activities.
get ready to
The rat-
answer. So, what are we seeing right here? It looks like some pipes and something leaving those pipes, emitting certain gases into the atmosphere. Right? And it looks like this might be a factory. Can you tell us a little bit about what we're seeing, Ethan? What do you see? What do you think you're
I see smoke coming out of a factory, And I also see a minecart with code.
Yes. And Jihan, do you think we can pull up that graph and what that means? Global mean surface temperature. What does this graph look like? Temperature is on the y-axis going up, and then time from 1880 to 2010. What's the significance of the year 1880? Do you think? Why do you think suddenly temperatures are going up?
Because of global warming.
Wow, that is a key word. Ding, ding, ding. Right now, I think we hear that word everywhere these days.
We should be aware all the time. We should be remembering that word all the time because it is our biggest problem. Yeah.
And I think one of these days we're gonna do a STEM question, like a STEM show on global warming. I think we're gonna do that. So keep that word in mind, listeners, viewers, wherever you are. But I think let's go into our next question and we can break everything down, what we see in this video and what global warming really means. Okay? So what is the measured unit used to calculate people's harmful impact on the atmosphere? Is it A, carbon footprint, B, oxygen footprint, C, nitrogen footprint, or D, hydrogen footprint?
I can't see the question.
Yeah.
So
Yeah, I can see it.
while you're answering, I'm just gonna break this down a little bit. The atmosphere is everything that's surrounding our Earth. The air has a lot of different gases in it. It's the oxygen we breathe, there's nitrogen in there, there's even a little bit of helium, a lot of different stuff. And there's these things called, should I say it? Maybe I'll wait until we get our answers and then we can talk about what the right answer is and why. Are we getting our answers in, Jihan?
Yes, right away. And here is our answer. And like according to the results, we have more viewers. They go with a carbon footprint, but we have some who says oxygen footprint as well. So that would be nice to hear more explanations about that.
Exactly. So first off, Ethan, did you guess correctly?
Yeah.
Did you guess carbon footprint? Okay,
Yeah.
that's great. I want to hear from you first. Why do you think it's carbon footprint? What do you know about carbon? What is
Carbon dioxide. When we breathe in oxygen, we breathe out carbon dioxide. That's the first thing which I learned about carbon dioxide.
Wow, okay. So it means we're producing carbon dioxide. And to connect it back to that video, those factories also release carbon dioxide or other gases that contribute to the gases in the atmosphere, right?
Yeah.
And so a carbon footprint essentially is our contribution to the carbon in our atmosphere. And this carbon, I think looking at this graph means that if there's more carbon or carbon-like gases in there, carbon dioxide gases in the atmosphere, it leads to higher temperatures. Do we know what that effect is called? Maybe we can think about farmers and where they grow plants. Do you know they grow them out in fields, but where else do they grow? Okay, Ethan, I see your hand up.
Wait, I want to say something else, but I didn't know the answer. So, the Earth's atmosphere acts like a greenhouse. So, when this carbon dioxide and other gases come up to the air, the atmosphere won't leave the air. So, all of this smoke, carbon dioxide, and all, they build up and create. So, when they build up, the heat goes more high, and then farmers won't be able to grow crops.
Wow, I heard so many keywords there, and one of them was greenhouse, was exactly where I was trying to get at, a greenhouse effect. So I'm going to just break it down. When we emit, you and I are breathing out a lot of carbon dioxide. Let's do a little bit. Well, we're just contributing just a little bit by breathing, but factories are constantly putting out carbon dioxide and other gases out there, creating this greenhouse effect, right? They're trapping heat. They're essentially using those gases, those go up in our atmosphere and they trap heat. And so the light that we get from the sun can't escape to go back out. So now it's just heat is warming up the planet a little bit. And I think the bigger our carbon footprint is, it means the more carbon dioxide we contribute and the more greenhouse gases stay. So, greenhouse gases, greenhouse effect, carbon, carbon dioxide, and a lot of factories. And in the 1880s, what happened in history that do you think contributed to all of these carbon dioxide, greenhouse gases being emitted? Yeet, do you know a little bit of history?
I would guess the answer to this. I probably think it's the Industrial Revolution that happened. So Ethan gave a great answer in my opinion, saying that this was just the perfect summary of what global warming looks like. But I was gonna ask, so global warming became a bigger problem after the Industrial Revolution. Is that the case, Island?
That's exactly right. It's a perfect correlation. You know, there was suddenly an increase of factories releasing all of these gases, carbon, methane, carbon dioxide, other type of carbon-based gases, and it has contributed to the warming of our planet, which is, a little problematic. And we can talk about that maybe at a later point, but it's really important to know what climate changes, global warming, and what carbon and carbon footprints is. And always, I think, thinking about how we as individuals and as a society can maybe make those temperatures go down and release less carbon dioxide gases.
Yeah, definitely. And the good thing is that okay, this is a problem, but we know that. And yesterday was the World Environment Day, Eileen, right?
Oh,
So
yes.
yeah, we celebrate the world. And did you know that, Ethan? Yesterday was
Yeah.
World Environment Day. So
Yes.
did you celebrate it?
For school, we needed to make a project.
Yeah,
So
perfect.
we made the project. And
Yes.
then,
What did you do?
so our project was we needed to choose an invertebrate animal. So we need to make a model of it and a model of its habitat.
Perfect. And I'm really happy to hear that because we know that there is a problem, and of course we should talk about it. Everyone should know about it, but also we should act on it, right? Because this is today's problem, and how we will act on it. And there are like scientific ways. One is using of renewable energy, right? What kind of renewable energy types, like, do you know, Ethan?
Can you say it again? I couldn't hear you.
Renewable energy, renewable.
Oh, okay.
Do you know any type of it? Like there is one on top, like out there on the sky.
Oh, okay. Hydroelectricity, solar electricity, and wind energy.
Yeah, perfect. So these are out there, and they will continue to be out there, no matter we are using them or not. Okay, so they are renewable, and let's get use of it and increase the usage of renewable energy and decrease this temperature anomaly, right?
Yeah,
Yeah.
exactly. And I think that's such an important part because fossil fuel, let's bring up the word fossil fuel, another key word.
Mhm.
Fossil fuels are those things that we burn that contribute to global warming. And those are finite, meaning there's only a limited amount of them on our earth. We can't, once they're gone, or it takes millions of years to get them back. And they're not the best for our planet. So, renewable energy, exactly what Jihan was saying, the sunlight is going to be shining down on us whether we use it or not. So, if we use it, it would be great to replace it with, instead of using fossil fuels. And those are a great way that all of us can contribute to reducing carbon emissions. Yes, Ethan, I see your hand.
Yeah. So to make planes, we use aluminium. And when we use a lot of aluminium, it releases 1.5 tons of carbon dioxide in the air. So
Wow.
instead of using aluminium, we can use manganese, which is safe, it's very easy to find, and it doesn't release any bad gases for our planet.
Wow, so it's not just what energy that we use to create electricity or anything, it's even the products that we use in our daily lives, like plastics. There's so many different things we can use than plastics, right? Plastics stay in our environment, they're a fossil fuel based thing, but exactly what you were saying about aluminum, we could use something else. There's alternatives, like those are great alternative sources. And I just learned something new. My mind is blown right now.
And like from Ethan's point of view, it is very important to know that our consumption affects this global warming as well. So we should act responsibly. We should buy responsibly as well. And this graph actually shows this is a metric from 2016, and this like per capita CO2 emissions, it says, right? So world largest economies, starting from United States to go to India, they produce this much of carbon in metric tons, and this is a lot of carbon, guys. And OECD average and world average is there. So in order to like decrease the carbon footprint, all of these countries should go lower, lower and lower. And how will we do this? Like the secret is to use like environment friendly materials, right? To decrease the usage of cars, maybe more bikes.
Transportation, more
Yeah.
bikes.
Yeah. What else? Like recycling, right? Like we shouldn't produce more. We should focus on recycling what we have produced. We should treat our waste responsibly again. So all of the electric cars is another alternative. And I know like engineers are working on solar planes capable of flying with solar power only. So that's another nice thing to hear. And I am very hopeful about the future. With people like Ethan, we will be solving these problems once and for all.
Exactly. Ethan, you knowing about aluminum and manganese and the alternative right there, it makes me so hopeful that you are going to come up with another material that we can use that's more sustainable and greener. Like, that was amazing. I just learned something from you. Thank you.
Wait, I want to say one more thing. So to make houses, we use bricks, and to make bricks, we use cement and heat it. So instead of using the cement, we can use fly ash bricks. So when we burn things, we get ashes, and with that, we can make bricks. We do not need to heat to make them bricks. We just need to leave them out in the sun. So that would be more better instead of using cement.
My gosh. Yes, that's perfect. I've just learned another thing. I haven't heard of that before.
Yeah, and
Wow, okay.
this has another important thing, Aline, and I will skip to the next question after that. You know, I was working on solar energy. I was building solar power systems, Ethan, like 3 years ago. Now I'm working in Twin. And when I was working then, I learned this kind of stuff like Ethan shared. And this thing is like local solutions. Like we are trying to produce lots of bricks on somewhere and transporting them to different locations and like creating carbon dioxide while transporting. Instead of doing that, we can use local materials. Okay, we can produce like nearby cities. We can decrease the amount of transportation, and this is another positive impact on climate. Thanks, Ethan. We should definitely have the global warming show with you, with all the things that you have mentioned. I think that will be a very fruitful show. So next question.
Yes, exactly. So this next question, we're gonna ask, what do you see in this picture? An insect egg, a seed, C, a ringstone, or D, a spider? I'm honestly unsure because to me it looks like a mirror.
You're not sure what it is. I think so. I'm correct.
It is like mirror, right? It's like one like artificial thing, like maybe cover and
It
these
looks like
little
this was
mirror
a-
pieces, huh?
I thought this was a Christmas tree decoration, but then when I heard the question, then I knew it was something else.
Yeah. So
Humans made. It's something you'd find in nature, supposedly. What do you think our viewers are thinking? What do you think they're saying?
yeah, we have a separation. Like everyone like goes everywhere in this question. No consensus at all. Uh, so maybe we can show the picture, but I don't want to like I want to talk a little bit more about this picture. So Ethan, you see like a tree decoration or something. Like what do you see
Yeah, I
in
thought
here?
it was a Christmas tree
Like
decoration.
what do you see in here? In here?
I okay, I do not know what that is,
No, not no. So yeah, I
but
need.
Those could be legs, if you ask me.
Because I can also see like little hairs,
Hairs.
hair pointy things coming out. Maybe yeah, it's a leg indeed. Maybe.
Yeah, so it has to be maybe. So, out of all of the questions that we had, I'm going to remind you an insect egg, a seed, a ringstone, and a spider. Which one of these have legs? I don't know what a ringstone is, if I'm telling the truth.
yeah, even I do not know.
Yeah, I don't even know. But which one of these would have legs?
A spider.
A spider.
Even insects can have.
And
Oh, okay, that's a spider.
exactly. It looks like we tricked everyone with this, and it was on purpose. I think this spider is doing something that makes it a little bit different than other spiders in nature, right? So okay, I said my first impression that this spider was a mirror, right? It looked like there's glass on it. Well, in fact, this spider's name is called a mirror spider. Crazy, right? So these spiders are called mirror spiders or sequin spiders. You know, like Christmas tree decorations have sequins on them. So you were very close too. They're all members of a different species of spiders. So these features reflect silvery patches on their abdomen, and they look like solid pieces of mirror glued to the spider's back. But in fact, they make them themselves. They can change size depending on how threatened they might be,
Oh.
or the angle they can change, perhaps using their abdomens to protect them against predators from different directions. And they are made up of a reflective thing called guanine.
Oh, I was going to ask that, like, how come? Because, like, it has something to do with, again, reflection, and they look like whitish, at least, like mirror, like, whatever comes, they reflect it, right?
Looks transparent.
Yeah, almost transparent, yeah.
Why do you think these spiders are special like this? Like, what do you think it could do?
I think it's like a camouflage. Camouflage.
Whoa. Okay, that's a cool keyword right there.
But except one thing. On the abdomen, there's something which looks like an owl made out of gems.
Mm-hmm.
The second picture.
So it could be for camouflage. What does camouflage do? How does camouflage help, let's say, a spider in this case?
Camouflage means that it can adapt to its surroundings. It can look like it's so if an insect is right next to a tree or there's a owl, next to a tree. So there's an owl which looks like a tree. It has the kind of wood carvings on it, and if that owl is right next to the tree, it might look like it is that tree. So if predators who eat these owls, and if they look at the tree, they will not know that this is the owl which they eat. They'll just think it's just the tree.
Actually, like think of it. I am going for a hunt, and I am following a like mirror spider. Okay. So all the thing, like all I see will be me. Like I will be looking to a mirror because like it is reflecting light, right? So think about like another animal approaching to mirror spider until it sees itself back. Yeah, Ethan.
I have a doubt. So, in real, does all mirror spiders have those kind of owl thing on the abdomen?
I
I
think they. So we saw two different pictures of those spiders. One of them had more of an owl, like red, yellow, and then like that mirror patch. And then there's another one that had more mirror patches around. And like I said, they can change the size of the mirrors, they can change the angles, just depending on how they feel danger around them. So if they have maybe a bird that they like to eat these spiders and the spider really wants to get this like stay safe, they might change the pattern of these mirrors and scales on them. So I would say that every spider is probably pretty unique and there's not something uniform about them, but there might be different spiders that have the same kind of pattern, just very different. It's like a thumbprint. Everyone has a different thumbprint, right? And so these spiders are probably pretty unique in how they look. Yeah, look at
Yeah.
that. The mirror spider, sequin spider. Oh, and they look like they live in Australia here.
Yeah, and the sizes are really small, right? Like this.
And I saw that the abdomen, the thing which I told you was a Christmas decoration. At the first, I thought it was an ant egg, and then that's when I realized from a National Geographic book, the people in Mexico eat ant eggs, and then I saw the egg does not look like that.
Yeah, that's very interesting here. And I think, why do you think it might be different colors? There might be for show, or do you think it's resembling something around
It's resembling something.
that? Yeah. So, like, let's say they want to hide some, from a bird. They might jump into a flower and kind of reflect the colors of the flower and look like the flower itself. And it's exactly as you said, camouflage. These spiders, over a long period, evolved to look like their surroundings, and it's somewhat like a bit of an illusion, right?
Yeah,
So it makes it hard to see. Even I had like that, a couple of those, like right here. If I wasn't looking and I didn't know what I was looking for, I would probably pass that spider if I were a bird, and I wouldn't eat it.
yeah, and it looks like something valuable, like shiny. And I might, if I see it, I thought maybe and it is like this small. It's like coin. It's like something precious, like you hang somewhere. But it is kind of an illusion, and we have the illusion question next. So,
Exactly. Illusions are great.
Ethan, wait, Ethan, you know lots of stuff, mate. Because of that, I just want you to wait until the question is asked to our viewers, okay? If you know
No,
the
I was
answer.
just saying that's Americans Got Talent.
Yeah.
Yeah, exactly. So this guy is illusionist, and we're gonna watch this, and once we watch this, I'm gonna ask you guys. So how does the illusionist make the salt disappear? Is it A, he's really making it disappear and then he brings it back? B, he wears a
Eileen, just a second. Maybe we can watch the video first.
Oh, of
Yeah.
course.
Okay. So, just look at him. What's he
You
doing?
know the whole answer for this.
And the sword came back. No. the salt is there.
They're
No.
surprised. I'm as surprised as him.
How come? Wait. Again, glass. Oh,
Putting water this time.
yeah, water inside is. Oh, water. Where's that? It's gone. Oh, water came out of it. It's pretty strange. Salt goes in, nothing goes out, comes out. Oh, I mean, is it magic? Of course not. I think it is not magic, and there's science behind it. Aylin, maybe we can direct the question.
There's a trick for it.
So how does the illusionist make the salt disappear? A, he really makes it disappear and then brings it back. B, he wears a cap on his thumb and pours the salt in there. C, he pours the salt on the floor. Or D, none of these.
I think he cannot make. I mean, he cannot make it disappear and then bring it back, right? I mean, none of them matters. Like nothing. No one can do that.
There's one universal law, like one of the universal laws is that you can't create matter or like take matter away. It can't
Yeah.
disappear,
Yeah.
right? So there's probably no way he's making it disappear and then he's creating salt again.
Yeah.
So we could probably say it's not A,
Yeah.
but let's see. What do our viewers think it is? What do you think it is, Ethan?
Since I watched this, I know the answer.
Oh, okay. You definitely so you've
Okay.
watched this. Okay.
Yeah, you can give the answer. Some of our viewers, some of our viewers say C. He pours the salt on the floor, but we saw that actually nothing was going on the floor. Maybe we can check it from here. So
When my mom and me watched this, I was so confused, thinking, how in the world did it go?
so we see like nothing goes. You were surprised, right? What do you think, Ethan? The answer is
B.
B. So let's see. Maybe we can have
Blazing
a,
salt.
we can
Blazing salt.
have a close up. And he's so like acting fast, right?
I think I saw something.
You saw something?
Yeah. Right. Wait. Right around here. He's saying, look over here, but then he does something like this.
Yeah.
Something with his thumb.
Yeah.
And he's removing the cap out.
Ah, there's a cap.
There's a cap. Just pouring in a cap and
Yeah.
pouring it out
I'm putting-
again.
And then he wears it again.
Oh, the cap is like finger-like. Oh, it is visible in here. You see
Yeah.
the color difference? Yeah. Of course, that is like people say they are magician, but they are just illusionist. Yeah, like this, and it stays inside, and then pours it, and then once it's finished, he like puts it back like this, and then it is yeah, perfect. Very
Oh,
simple.
he puts it in his other hand.
Yeah.
Exactly. So he's very fast. Illusionists oftentimes say, look over here, and then they're doing something on the other side.
Yeah.
And I know someone with a Yeats is actually somewhat of an illusionist himself, I would say. He does something that a lot of people don't usually do, and I think you can explain a little bit of what you do, perhaps.
Yeah, but before that, before that, let's maybe show a video clip that Yeet made. Ethan and all of our viewers, please, like, Yeet shared this movie with me, and he produced it. He like made the story, like made the shot, post-production, music, and everything, and it's pretty exciting. So let's see it together. It's a short, funny, exciting movie. Ethan, what did you understand from this?
I did not understand anything. The only thing I understood was that Eat made it.
Yeah, he made it. So, do you have any question to Eat about this?
Yeah.
Yeah, please. I'll
I have a
ask me.
question.
Yeah.
That number one was that how did you make it without using your hands?
So Ethan, I think the answer to this question is kind of related to what we saw before. Filmmaking is also kind of like an illusion. Like what we see here, each frame is a photo. This is called the stop motion technique. I put the camera up on top of the table and moved the items very slightly, and then took photo every single time that I moved a single part of the items. And then when you combine them together, what you end up with is kind of an illusion of motion. Motion doesn't exist, but there's an illusion of it. So that's how I made it.
Yeah, now I understand. It's like a flip book.
Exactly.
Yeah.
Exactly.
Flip art, definitely. And Yiğit, I have a question about this. How many photo did you take for this project?
Great question. I think it was around 800. It should be around 800.
800 photos. And how long does it take to finish all the project, like the post-production, music, and preparation, everything?
Something like this, if you're working on your own, it takes a while because you start working in the pre-production stages all the way to the post-production. So it kind of takes like 2 weeks, 1 week to 2 weeks. And this is such a short movie.
Yeah, like 30 seconds.
Yeah, exactly. You work for 2 weeks and then you end up with a 30-second short movie.
And when did you do that?
This was back in middle school when I was going to the 7th grade.
Ethan, which grade are you?
Fifth.
Fifth. So Ethan at fifth grade is doing projects about global warming, right? Yiğit at seventh grade, he was doing projects about movies, right? So what is Yiğit doing right now? Let's see. Ethan, do you want to learn more about what is he doing?
Yeah.
Okay. Yiğit, what is neuroscience? I mean, and how does it relate with film and visual studies? Like, I'm confused here.
That's a great question, Jihan. Well, my passion for filmmaking started back when I was a child, when I was like 5 years old, and I've always wanted to make films all my life. The neuroscience part of it became a passion when I started going to the university at Harvard. I started taking psychology lessons and neuroscience lessons and evolution of brain lessons about those. And then suddenly I was inspired about how the human mind works, how it works the way it does. And I thought learning more about the human brain could also improve my filmmaking skills in terms of like, how do humans behave? How can I portray these ideas in movies? So that's how my passion for neuroscience started, and I wanted to combine those two in the academic field. So that's when I decided I want to do a double major.
Wow. Wow.
That's amazing. Very, very cool that you're combining two very different fields in a very unique way and just contributing to like a new understanding of how we see things, how we watch things, and understanding how our brain works. That's amazing. Ethan, yeah, go ahead, ask away.
Yeah, I have only made flip books and editing pictures and making videos, but I have never ever made an animation like how each made.
Yeah.
Are you inspired to make a stop motion animation like Yeet now?
Yeah, but not in fifth grade.
So yeah, so like I was saying that Ethan actually, like when I was a kid I was working on something as well, then those skills actually made me who I am right now, and all of these like work Yiğit has been doing, like those works shaped his perspective. And the things that you have just told to us about global warming, like I am able to see you like 20 years from now on, and like kids like you working on beneficial technologies, like good technologies for people. So thank you, Yiğit. I mean, do you have any other question, Ethan, to Yiğit?
No.
No. Guys, please, if you have any interest on flip art, you can make your own flip art movies and share it inside of Artvin mobile application. And then we can jump into our next question. Yiğit, do you have anything to add?
That's all. All I can say is you don't need that much of an equipment to create the movies you would like to create. I only had like a phone camera and a piece of paper. It's just the amount of time and effort you put. So don't be restricted by the amount of equipment you have. With the smallest things that you have, you can make amazing stuff.
In fact, it might even force you to be more creative.
I totally agree.
Yeah.
So this is a creative
Hello?
solution.
Hello?
Yeah, Ethan?
I'll rejoin right now. Something happened to the laptop.
Okay, so we are able to see you. So maybe you can mute yourself and solve the problem, and then.
No. The thing is that the laptop went black out. So I'll just switch it off and then I'll join back.
Okay, Ethan, thank you. And we will continue with the last question. So this is a creative one. Aylin.
So, leaderboards, people ready to win the robotic art kit. This is our last question, so pay attention to this photo, and we're gonna ask, what is wrong in this picture?
Hey, hello, can you hear me?
Yes, Ethan.
Yes, Ethan, we can hear you.
Yeah.
We're asking our next question. What is wrong in this picture? A, they use yellow paint. B, there aren't many people around. C, the paint doesn't smell like perfume. Or D, they're painting without any precaution. So get ready out there. You have 20 seconds to answer. And at the end, we'll see who is our leaderboard high score.
I have the results now. And we have our leaderboards ready. After the explanation, we will share the leaderboard, guys. So what do you think, Ethan? Aylin, what do you think?
I think all of them are probably true. Like, the paint doesn't smell like perfume, I can guess. But I think what's wrong in this picture, I don't think it's healthy breathing in certain things like paint like that. So
But-
I
I'm
also think it's D.
Yeah, okay, great. I'm not the only one that thinks that. So the correct answer is D. They're painting without any precaution. They're not wearing masks, they're not wearing gloves, and a lot of the times those types of paints can be pretty poisonous, so you don't want them to be on you or in your lungs. We want to keep our lungs nice and clean with only fresh oxygen, and we want to protect our hands and clothing, make sure that we're protecting ourselves in everything we do. And this guy right here, he's a professional.
Yeah, definitely a professional one. Very neat, right? Clear and mask.
Yeah, he's thinking about his health right now. So when we're going outdoors and there's a lot of pollution in the air, even, we want to wear masks. Or when we're doing anything with painting, aerosols, anything like that where we can breathe it in, that's what we would want to do, is protect ourselves and always be cautious of what we're doing and making sure that we're protecting ourselves, because we're going to be doing a lot of things sometimes that need to, not just painting, but if you're at a construction site, wear a helmet, you got to protect the noggin, right? Or if you're doing anything with something sharp, gloves.
Mm-hmm.
So this is a lesson that we just want to make sure everyone learns, and whatever you're doing, just paying attention and make sure we're taking the necessary precautions, because it's really important to protect yourselves so we can continue making really cool things, maybe a stop motion or painting a car or whatever activities you like to do. Skateboarding was one of mine, so I always had elbow pads, knee pads, and a helmet.
Perfect. So I think we are at the end of the show, and it's time to announce our. Oh, Ethan, you have a question. Please go ahead.
So the photo which was shown, was it a part of a cycle?
This photo.
Yeah, what is that?
So yeah, it's a bicycle, part of bicycle, and they are painting it. But as you can see, some paint on his cheek, hand, and he is directly breathing all the gases coming out of this paint. And I tell you that it is not healthy. It doesn't smell good. And whenever you see a picture like this, please take a little bit, like take a couple of steps back and warn them to wear the necessary equipment, guys. So it's time to announce the winner, Eileen.
Drum roll, please.
Drum voices all over, all over. And 3, 2, 1. Here are the results, and Ada Lovelace takes the lead and wins the robotic art kit, and she will be doing lots of different experiments with robotic art kit. We are congratulating her, and please Ada, share your experiments inside of the TV mobile application as well. And I have a couple of announcements, and I will give the word to you, Eileen, for the wrap up. Whoever wants to be involved our live STEM show, they can reach us through our mobile application. What they need to do, they need to go to profile and then click these 3 dots here and then contact us and then start a conversation. So by doing so, you will be here with us. You will have the chance to be here with us like Ethan, and we will be discussing all the questions in live STEM show. So, okay, Eileen, everything is...
Everything's great. I had so much fun. Thank you, Ethan, for joining us. I can't wait to see who joins us next week. Again, the Twin mobile app, please contact us. We would love to meet you. And everyone who wants to join in next week, we look forward to seeing what kind of adventure we're going to have with you. Thank you so much, and we can't wait to give away another robotic art kit to our next winner. So I want to say a big thank you to everyone. If anyone wants to say anything, Yeats, you're a great role model. I appreciate everything you shared with us. Any last words?
It was a pleasure. I learned a lot during this live STEM show. Ethan, thank you so much for all the nice information you gave us. Jan, Eileen, thank you so much. It was a great pleasure.
Thank you. It was a pleasure as well here. Thank you so much.
Ethan, do you have anything to say?
The only thing I've got to say is thank you for letting me be the host for this STEM quest.
No worries, you are welcome. Yeah, you are
Can't wait
amazing.
to have you again, please. Next show, anytime. You know so much about climate change and global warming. I can't wait to see what else you know in that amazing brain of yours. So thank you.
We are closing the show, guys. Thanks for watching, and we are closing it with our great adventure. If you haven't tried yet, please go to Twin app and play this adventure. So let's see you next week.
Going to space to visit the sun. All aboard the Rocket Twin. Hopefully you will learn enough from the sun to bring electricity back to the island. Ready to leave Earth? Buckle up.
Bye-bye, everyone. Have a great day. Good